Hallo, hallo. Hallo. Ага. Labdien, labdien! Jā, kura puse kanāla vai. Jā, tūlīt būšu. Okay. Mhm. minutes. Let's see what we can do. No, stop. Come on. This is fine. This is fine, this is fine. Okay. What's here? Yeah. 1 second. Well. Yes. Okay. Okay, here I am. I will have to attend another meeting. That's why today I'll be. Today will actually be short, but anyway, we need to start. Idea of numerical filtering or digital filtering. What's all about? Where we are and what we are talking about. Let's try to look on our intellectual device. What we have in general. Box. We have analog, let's say XA1, XA, and good morning. Analog. This may be UA, UE, UC, EA, EE, and so on. All these values are something like sine omega. Currents, voltages, maybe something, I don't know, something from pressure sensor, temperature. And we have binary. Binary, logical signal, switch on, switches on, switches off, and so on. All this goes into our device. Our device produces outputs. One, no, many outputs. What are these outputs? They can be analog, but mostly they are binary. What it can be? Disconnect switch, disconnect switch, increase excitement current, decrease excitement current. How they are formed? We have analog part, we have binary part logic, and we have output. If we look what's here inside, in general, what it should be? Outputs are results. We have set of function f1 x 1 xn later when say what is some constant. Fn x1 xn greater than some constant. What are these constants? Settings. We need to have, we need margins. These constants are elements of array of settings. So something, some kind of function calculated on the basis of input signal should be compared to some thresholds. If above, we need to take an action. Starting from simple sending a signal, oh, something wrong, and ending with global decision to separate power system in parts. The asynchronous regime automation, one of the most responsible, takes its action is to separate whole system. It can separate nationwide system from in parts or from neighboring countries. One of the most responsible automation. So why I'm talking about it, about this? Sounds like a what? What can be, let's say, easiest example of function? What it can be? If AI greater than E trip or EB greater than E trip or IC greater than E trip, if any, then what? Disconnect. Send a disconnection pulse to declaration. Oh. And here, greater, greater, greater. Greater, greater, greater. What do we have? At this point, we knew how ADC works. Yeah? What do we have? If A greater than A. This one is constant. Okay, but what here? We have E maximum. White line is E maximum sine omega t. Yeah? It's input of our current transformer. What next? We perform an ADC conversion, yeah? Analog filtering and ADC conversion. This one is current as a function of I tau, where tau is sampling interval. This from your electrotechnics theory. How can you compare red dots with a constant? On instant values, in terms of electrotechnic basics. What is this? Current is bigger. Or 1, 2, 3 meters, 4 meters, 5 meters. What do they show me? If instead of device there would be a human, if current is above 2.5, disconnect. What's the physical meaning of 2.5? What this matter shows to me? Power factor? No, power. This one shows power factor. Here is amperes, 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 amperes. But what's the meaning? What's amperes? Okay, current. More. What is effective value? What's the idea behind effective value or RMS? What RMS mean? What's the meaning of RMS? Yeah, root mean square. And physical, what is this? No, it's not an amplitude. If it's written like this, most probably this value, EA, should be RMS. But what is RMS? What is hidden? What really shows this matter? It's written amperes. Once it was calibrated, it had paper stamped. I have one with papers. What's the real meaning of 2.5? You have basics of electrotechnics in your curriculum. Current before fault, current after fault. Threshold I defined. If current exceeds this line, both in amperes. What should I compare? This threshold is defined for this RMS or effective value. But what is effective value? Ask your AI assistant, what is effective value or RMS? What's the physical meaning of this meta readings? pretend to show same. This voltage, current, voltage. This one pretends to show the same. The same physical. Eh? Any ideas? You should know it.
Is equal to the DC current?
Close. Close. It's not what means equal. If you connect this to your AC circuit and some DC circuit to the resistors of same value, DC current producing as much heat as this AC current will be its RMS equivalent or effective value. If I power here I should switch on. For example, here I have DC network 220 volts. If I connect it to this one, it will produce, emit heat and light of 1 kilowatt. Connected to AC, I need, in case of pure AC, 311 volts, square root from 2. For pure sine, ratio between DC and AC, effective value, square root from 2. So, if I have magnitude 220 square roots from 2, they will produce same 1000 watts. So effective value is DC current or voltage producing same amount of energy, in case of active watt, same amount of heat as measurable AC. Equivalent in energy. Why I'm talking about it? In electrotechnics theory, we have written in how to say, this covenant, this trip condition, written in terms of effective values. It's natural for human. For you, looking for ampere meter, you don't even understand what it shows. It measures currents in amperes. Ampere meters matters in amperes. In reality, if you look deeper, this meter shows you effective value of current. If you would like to disconnect, for example, we have simple protective device, overcurrent protection. Okay, this relay is overcurrent protection. If line current is above threshold, I said, for example, 20% above maximum possible load current. If above threshold, to disconnect. For me, I am a customer. I'm ordering protective device. I would like it be, how to say, my knowledge friendly. If I knew what 1 kilowatt consumes 5 amps, 20% above, okay, 10 or 16 amps. I would like to disconnect line if current exceeds 16 amps. It's normal. Normal, it's where it is. It's idea for simple circuit breaker. What's inside simple circuit breaker? Thermal element, yeah? Thermal elements reacts to effective value. It is resistor heated by current. For thermal element, it's not important what kind of current flows through it. Important amount of heat producing, yeah? So it reacts to effective value. You can have rectangular current. Anyway, for simple circuit, this miniature, okay, it's a miniature circuit breaker. For miniature circuit breaker, important is only amount of heat in its sensor. Customer will not understand if I ask him to input some instant values. If in sequence so many instant values exceed, what is? Customer would ask me to input, to program my device in simple thing, in amperes. But these amperes, for me, what I need to use for my device, if my customer would like to input this trip threshold in amps of effective value. Customer don't understand what is effective value. May not understand. May. Okay, I have a smart customer. I would like smart customers. But I should understand it. So, what I need to do? I need to compare effective value to threshold of effective value. I cannot compare instant and effective. I should compare what? Oh, come on. Maybe should let the rules we had spoken about effective values, but simple overcurrent relay, simple thing, overcurrent relay. If I like to, let's say, if I would like to sell it, I need to make it customer friendly, and my customer programming overcurrent relay would like to program disconnection current, this trip threshold, in effective values. Okay, and now tiny question. What do I have? I have flow of measurements from analog to DC converters, yeah? Flow of points. How can I, it's a simple thing, how can I compare flow of points with line, which physical meaning is equivalent DC current? Huh? Here is simple example of filtering we may apply. Here are my dots, my points. It's continuous flow. For example, let's say this device. Every millisecond I have one measurement of current. They came with a step 1 millisecond. I need effective value. In master RMS is square root 1 divided by period. Wait, say current as a function of period square. Okay, familiar something? Yes, 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 yes. One period of current. Ideal current. One set of points. Point 1, point 2, point 3, point n. I have n points. Actually, if I have space 1 millisecond, I will have 10 points. These are measurements my ADC took. They are in my device memory. What a physical meaning of this integral? Of this part? What's physical meaning? Area. Sine square omega time (20 millisecond) area of this figure of square. Area. So what can I do? For this area, again, I have measurements. I can substitute this area, this what? I can take this area numerically. I can substitute, not absolutely precise, but I can substitute necessary area of sine square. It will be, in real life, it will not be pure sine square. It will have, it possible will have a periodic components. Not important. Important what I can also substitute area of line figure with sum of these rectangles. Instead, I can calculate this numerical. So if I have n points per period, per one period, I can substitute RMS with square root 1 divided by number of points. Sum I starts from 1 and to number of points. I square tau. Fine? You understand this formula? How can I get it? Because this thing, this dimension is I square. If this is measurement number I, so it will be I measurement square, and width is period divided by number 1 tau. Fine formula. You like this formula? appears nice. If I put this in device, my boss will fire me immediately. Why? First, square root. It's a very slow function. You understand what? It's a sliding window. Normal current, full current. I have, in reality, I have a sliding window of n points. It slides all through. For this window, for each moment, one measurement, what I need to do? In each millisecond, I need to remove this point. Each millisecond, it moves forward 1 millisecond. In each millisecond, it moves forward 1 point. So this point should be excluded, and this point should come in. Calculating for each millisecond square root is absolutely stupid. So what I do, no square roots here. I need to compare to square. It's very simple. If you need square root, never use this row or series extension of square root. Substitute it with x squared equals with solution of nonlinear equation. You can do it very fast, in very fast manner with the section. Here, I have a sliding window of square, average of square. This will be constant. This thing don't change. Changes sum of squares. Sliding window, one step down, 1 minus, 1 plus, y minus, 1 plus, y minus, 1 plus. It will be like sliding train, but that's not all. Hysteresis. Remember this word? Hysteresis. In reality, I will have some kind of jitter. Also, remember what ADC give me? ADC produces in steps. What values in vertical, in magnitudes, are discrete. They come with steps. A0 divided where n is number of beats in ADC, number of steps. It's one moment. Second, folds itself not stationary. What it means? What to prevent multiple stupid trips, triple release, I need to have two thresholds. Understand? Time, effective value of current, forward, this is output, return. This delta is hysteresis. So in general, I need to produce two signals, to return and trigger. Okay, trigger. Trip jumps up, and only when trip may disappear, but only signal of return may release this trigger. And what else? I should not disconnect if it was a short spike, some kind of short glitch. Understand? Average saves me from glitch. Not 100%, but it's a well-working protection against short glitch, what maybe transient, just computation transients or lighting, something like this. Short average mass statistic. What is mass expectation of average? Of random? 0. So average of random will be 0. Since I use average, it reduces probability of first tripping on spikes. But not 100%. Most of them I need to ensure selectivity between, let's say, bus protection, customer line protection. They should, if there is faulted customer, first should trip customer protection, and only if unsuccessful, bus protection will operate. To achieve this, I need time. I need to separate them as time gaps to ensure selectivity. Okay, sorry, I need to attend. No, not bus. A meeting with the director of institute. So I need to cut. Next time I will show much more complex thing. I know what much complex. Phasers. This effective value works for simplest protection devices. One step up and we hit problem of phasers. It's a serious thing and I'll need my table. Okay, sorry. Today I have to